Hello friends, welcome to e-learning session on supervisory control and data acquisition system. In this session, we will see evolution of SCADA, definition of SCADA, SCADA system architecture, desirable properties and applications of SCADA. The evolution of SCADA system. The importance of SCADA systems is automation. The scope of SCADA has evolved from its beginnings in 1960s. It allows an organization to carefully study and anticipate the optimal response to measured conditions and execute those responses automatically every time. Relying on precise machine control for monitoring equipment and processes virtually eliminates human error. SCADA stands for Supervisory Control and Data Acquisition. SCADA is an industrial computer system that monitors and controls a process. In the case of the transmission and distribution elements of electrical utilities, SCADA will monitor substations, transformers, and other electrical assets. SCADA systems are typically used to control geographically dispersed assets that are often scattered over thousands of square kilometers. Definitions of SCADA. SCADA is a technology that enables a user to collect data from one or more distant facilities and or send limited control instructions to those facilities. Another definition of SCADA from IEEE standard, it is a system operating with coded signals over communication channels so as to provide control of remote terminal unit equipment. Let us have a look at SCADA system architecture. Specific terminology is associated with the components of SCADA systems. These SCADA elements are defined as operator, human-machine interface, master terminal unit, communication means, and remote terminal unit. Operator, human operator who monitors the SCADA system and performs supervisory control functions for the remote plant operations. Next block is human-machine interface. It presents data to the operator and provides for control inputs in a variety of formats, including graphics, schematics, windows, pull-down menus, touchscreens, and so on. Next is master terminal unit. It is equivalent to a master unit in a master and slave architecture. The master terminal unit presents data to the operator through the HMI, gathers data from the distant site, and transmits control signals to the remote site. The transmission rate of data between the MTU and the remote site is relatively low, and the control method is usually open loop because of possible time delays or data flow interruptions. The next important element of SCADA is communication means. Communication method between the MTU and remote controllers. Communication can be through the internet, wireless or wired networks, or the switched public telephone network. And the last element in the SCADA architecture is remote terminal unit, that is RTU. It functions as a slave in the master slave architecture. It sends control signals to the device under control, acquires data from these devices, and transmits the data to the MTU. An RTU may be a PLC. The data rate between the RTU and control device is relatively high, and the control method is usually closed loop control. Following figure summarizes the general state of SCADA at this time. The figure depicts a typical SCADA system that incorporates standard hardware and software platforms such as PCs and Windows. The SCADA system is linked to external networks, corporate IT solutions, remote, possibly insecure access points such as modems. There are two desirable properties of SCADA system. If the NERC definitions of adequacy and security were modified to apply to SCADA system in general as follows: adequacy, the capacity to meet system operating specifications within major component ratings in the presence of scheduled and unscheduled outage of system components or facilities. Security, a system's capability to withstand system disturbances arising from faults or unauthorized internal or external actions without further loss of facilities, compromise of human safety, and loss of production. Next, we'll look at the applications of SCADA. SCADA is widely used in different areas from chemical, gas, water, communications, and power system. So SCADA is very important in these critical infrastructures. The list of applications of SCADA are listed as: it is used in electric power system and operation control. SCADA systems are used in electric power generation plants, transmission area, and distribution system. Next area is manufacturing industries or plants. SCADA helps in management of different inventory items or raw materials, controlling of automated systems in synchronous manner. Next area is telecom and IT based systems. Management of different RF based systems, communication mediums, and large communication systems, including data logging through antennas, can be easily done through the SCADA. Next area is water and sewage treatment plants and supply management. SCADA-based systems are used by the state or municipal corporation to monitor, control, and regulate water capacities in reservoir. Next is traffic controls. SCADA helps in regulation of traffic signals, controls the traffic flow in railway systems, on-road systems, and air traffic controls. Next, lift and elevator controls. SCADA can also be used for lift and elevator controls. SCADA is used in buildings, facilities, and environments. Facility managers use SCADA to control HVAC, refrigeration units, lighting, and entry systems. And another area of SCADA where the SCADA is used is mass transit and railway traction. Transit authorities use SCADA to regulate electricity to subways, trams, and trolley buses, to automate traffic signals for railway system, to track and to locate trains and buses, and also to control railroad crossing gates.